Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to learn how to model this transformer. I'm using this simple circuit to know how to model transformer in LTspice. This box where you see L1, L2 with this note here, model a transformer in LTspice. So this is the first thing that we're going to look at it, and another things that we're going to see is that how the ratio between V out and V in is formulated in this simulation to get some intuition. This is the ratio between V out and V in, square root of L2 divided by L1. Okay, and we also know see how if we change the frequency of this sine wave as an input, how we can get the required output with the appropriate inductance L. Okay, so before we get started, if you're new here, please give me a thumbs up, hit that subscribe button, and also the notification bell, so whenever I upload a new video you'll be aware of it. Let's jump into it. This is my LTspice. I'm going to walk you through all the details, and I also use an important hotkeys in this simulation so you can get pretty well speed in your simulation. So hit V for bringing some voltage source, hit R and for resistor, and control R to rotate this resistor, hit L to bring some inductance, and again hit L for another inductance, another R that we needed, and hit W to wire these elements together. And also be careful, this is actually LTspice 2024. I think this is the last version of LTspice right now, and the hotkeys are a little bit different than the last versions, because in the last versions actually F3 was for wiring, but this is actually really appropriate and really close to what do we call in PSpice or in Altium, when we use Ctrl W, I think, in there to wiring some elements, so it's really close to them. Hit G for grounding your circuit, and now let's just define our elements. For example, this is a resistor to model some series resistance of the voltage source. For example, get this 1 million, and this is the output resistance. It doesn't really matter, we need some load to see our voltage. About these inductances, so here for example I have 2 microhenry inductance and show phase dot. Okay, phase dot in here, and again here for example 8 microhenry and show phase dot. Okay, so all the both phase dots are in the bottom plate of this inductance actually. So how we can get these inductances have a mutual inductance? We need some mutual inductance to make it as a transformer. Hit T for writing some comments, but hit SPICE directive to have this as a code in your simulation. K is the keyword for having a mutual inductance between those L1 and L2. So with a space you write L1, L2, and this is an integer between, actually this is a number, this is a floating number between 0 and 1. 1 means a complete coupling between these two inductance. Hit enter and place it, for example, in here. Okay, so this is the box that I've been telling you about a transformer, how to model a transformer. So let's just define my input. For example, by right click on this element and go to advanced, hit sign, for example 0 DC, offset voltage and amplitude of 1, and how about the frequency? For example, a frequency of 1 mega. I will be talking about frequency later on. Hit enter. So now, in order to see our waveforms, I need to actually label for input and output. Hit N for writing our label, V in for input, put it in here, and again hit N, V out as an output, which is here. And after that, you could hit ESC, scan. Okay, now we are ready to simulate. We just need to hit this button actually, and after that specify our time, stop time. For example, because we have 1 mega ohm as a frequency, so our stop time should be in the order of microhenry. For example, 4 microhenry, I think this would be enough. And now you had to actually specify your net labels. V in, this is our input, and here this is our output. Okay, now we get our result, but this is not just some kind of ratio. I wanna tell you that you have to know some background about formula, how this is gonna work, for you guys to get some great intuition about your design, about your circuit, or whatever it is. So here we have the ratio between L2 and L1, 8 divided by 2, which is 4. The square root of 4 is 2. So with 1 as an amplitude for our input, 2 should be in the amplitude of our output. So here you see that this is the blue line. Let me just change the color, maybe in red. So here we have 2 as an amplitude of our output, and here this is 1. You can see in here. When I place it, you can see it in here. This is 1. This is almost 1 for input, and this is 2 for our output. Okay. Now, one of my friends actually told me that about this circuit. He used this, but he didn't get the result that we're looking for, and this is some additional point that I want you to be careful about it. He changed this frequency of this signal, for example, into 50 hertz, the frequency 50 hertz. For 50 hertz, we need to actually change our stop time, because the one period of 50 hertz is about 20 milliseconds. So maybe to sing 2 periods, you need 40 milliseconds, okay? And then simulate it. So the result is different. As you see, the amplitude of output is not 2. It's actually down to 0.8. And this is because the impedance of inductance is so low. And I'm going to use my calculator. These are just some tools that you have to know and use it in your design. For example, this is the Excel sheet. Okay, what is our frequency? I'm going to put the label F and write the frequency. Frequency is 50 hertz. What is our inductance? For example, in the output we have L2 as 8 microhenry. You have to write it as 8 E minus 6 as an 8 microhenry. So what is the impedance? I'm going to show it with ZL in Excel. What is the this actually impedance of this inductance, this is actually 2 pi f multiplied by L. So I'm gonna write the formula in the Excel sheet. Okay, you have to choose this cell and then hit equal and then write your equation. 2 multiplied by pi, you need 2 parentheses, and then multiplied by this f frequency, after that multiplied by this cell of this Excel. Hit enter. This is actually the impedance of this inductance. As you can see, this is so low impedance, so you never get your result what you will expected. But if I do this, I want to calculate again this impedance. For example, with the same frequency, if I change this L into, for example, 8 Henry instead of 8 microhenry, what would be the result for our impedance? This is a great increase in impedance, and with this impedance you can get the result you're looking for. So let me just do that in this simulation. I'm going to change this L2 into 8, but in order to save the ratio as before, I have to change L1 from 2 microhenry to 200, and then again simulate this circuit. As you can see, you get the same results as before. So be careful about how to choose your frequency, about the relationship between the impedance of L, which I will again this is actually the impedance of L, 2 pi f L. This is the impedance of inductance. So be careful about how to choose this, and actually I want you to have some intuition into your design and have some feelings about what you're going to do. This is really important to you in order to become a good electronic designer. Okay guys, this is the end of this video. If you like this video, please give me a thumbs up and share this video with your friend. I will see you in the next video. Thanks for watching.